It's a bit like bittersweet. Studying past climates, like being a detective, trying to find out it's not what wasn't a crime, but what happened, who was responsible for those changes. The CO2 is constantly increasing, and if we will not stop emissions of carbon dioxide into the atmosphere, the climate will get more extreme and will become significantly warmer than it is today. So it is important to study past climates to understand what we can expect in the future. Around 16.9 million years ago. A similar climatic change already happened when the Earth climate experienced a rapid CO2 increase from around 300 ppm to above 500 ppm. And this time interval can be used as an analog for understanding our future climate changes. What can we experience? How will the weather change? How intense will be precipitation? How the temperature will change and how our vegetation will be impacted by this increasing CO2. The issue is that the CO2 is changing so quickly today that probably the climate is still not in equilibrium with this very high CO2. In my project, I was curious to find out how Denmark looked like in the past when the CO2 was around 500 to 600 ppm. And in order to do that, I decided to study the Miocene time period. The Miocene was a geological time period between 23 and 5 million years ago. Looking at the larger picture, the Miocene was not that different than its present. The continents were almost in the same position as they are today. Vegetation was also fairly similar. A lot of the flora and fauna which we know today has developed during the Miocene. The biggest difference is that the precipitation was much more intense. There was a lot of storms, and the storms were also very intense. So Miocene was generally warmer and much wetter than we know today.
That are 10 centimeters. Wow. So I need to take some samples from the top part here. And there were actually some microfossils in there, so I want to get some more of this material.
If you want to explore the Miocene and the Miocene climate, the best source of information are sediment cores, which are often collected from the bottom of the sea, and they can be used for studying the long-term evolution climate changes.
7 centimeters?
There are several different methods. You can, for example, look at the fossil plankton, and then you can find the changes into plankton through the time. You can study fossil spores and pollen, which are coming from plants, and that can give you information about the changes in the vegetation. So we can see the change from the plants which were tolerant to drier periods, or they were more dominating plants which were flourishing in the high precipitation climate. So if you are tracing these changes back in time, you can study the evolution of the climate. One of the methods for reconstructing atmospheric CO2 is looking at the stromata. So you're simply looking at the openings on the leaves, and there will be some changes in atmospheric CO2 which will impact the morphology of the leaf structure. If you find the same leaf from the Miocene and from today, you can look on the structure of the leaf, and that can tell you about the differences in the CO2. You can also do lab experiments when you are growing similar plants like the one you find in the fossil records under various CO2 reconstructions, and then you can compare the fossil leaf with the leaves from your culture experiments, and then you can see what is the most CO2 concentration similar to the fossil leaf.
Okay, there we go. 14 to 15.
When I take a sample from the core, I can decide which type of analysis I would like to do. A part of my sample will be analyzed for microfossils and pollen and spores, and the other part will be studied for biomarkers. Biomarkers is like studying a fingerprint of the organism which has been living in the past. And if you link to the organism which are living today, and you know what are the living conditions of this organism, changes again in the community of these organisms can tell you about the changes in the past. One of the organisms group which I'm studying are biomarkers which are coming from membrane lipids. Membrane lipids are produced by organisms to protect the cell in the same way like your skin protects your body. If it's too hot, you will sweat. When it's too cold, you will get goosebumps. And the membrane lipids will rearrange a bit of their structure to optimize the living condition for the organisms. So if you can correlate this one with the sea temperature changes, you can use that approach for studying temperature in the past. We really don't want to go back to the Miocene. It was really warm and very wet, and we really experienced extreme summers over the last few years. And this is only before we even reach the level of 450 ppm. So we can only expect more intense weather conditions. So we should do everything what we can to keep the atmospheric CO2 to the lowest possible level.